Okay, so I guess we'll proceed with Poppies, Pollinators, and People. I'm really looking forward to this because I haven't been a pollinator in a long time. But I'd like to let our guest take the program ahead. It should be fun.
I think
Well, you were at one point a pollinator.
I believe so.
Okay. Good to know.
How many species did you?
Have you ever seen an elephant?
Thank you for making me laugh. I appreciate it. And I guess I have not ever participated in a Zoom meeting as a speaker. So I'm going to look at the people in the room, and I don't know what effect that has on the people tuning in otherwise.
The camera's right there, so if you're looking over here, you're kind of looking towards the camera. The camera's the owl.
Oh, okay. I'm learning. So, hi, and I'm Alisa Seidlitz. Loving Gardens Designs is the name of my garden business, and I want to acknowledge, first of all, that we are on Ohlone unceded land, as well as this building is, and I'm grateful for that. So today, Massey Burke and I will be talking about habitats for both pollinators and for people, using natural materials and with regenerative intentions. Am I speaking for you? Well,
Sure. Yes.
So I am very grateful for this opportunity because the information really wants to be pollinating everywhere. So I'm going to give some fundamentals, and then I'm going to show a few little vignettes of what it's possible to accomplish in small urban spaces for the sake of the well-being of pollinators and thus mammals, and including human beings. So, my top 3 mottos are: beauty is a vital soul nutrient. So for human beings to thrive, we want spaces that have beauty. Plants are our elders. They've been on the planet far, far longer than human beings have, and we have a lot to learn from them. We've already learned a lot, and we have a lot more to go. They have a lot to teach us. And for this particular talk, the third one is delete concrete, because concrete is in the way of pollinators and in the way of all biological creatures, actually. In some limited capacities, it's needed and it's a blessing, but to the degree that we're able to either remove it, maybe show the first slide now, please, or never pour it to begin with, the better. This is a tiny spot, barely 3 feet in its longest dimension, which is feeding a lot of pollinators. So we have this space next to another part of a garden that we made next to another part of the sidewalk, and I figured, yeah, let's delete the concrete. And are you all right? Okay. Let's delete the concrete, and there are a lot of pollinator plants there, which are beloved. And usually deer don't touch them. So, let's see. As probably all of you are aware, pollinator populations have drastically, pretty catastrophically decreased in the last 50 years. Yes?
Can you define what a pollinator is?
Absolutely. It is a biological being, and there are many, which provides the service of transferring pollen from one plant to another.
So it could be something that flies.
It absolutely could be. I was going to ask people that later, but if you,
Okay.
no, absolutely, you're totally right. Something that flies.
I know about concrete, but not about pollinators.
Well, you know a little at least. So there's something that makes pollen move that isn't biological. Does anybody know what that is? Can you say it louder, please?
Wind.
She's right, wind. Wind is a pollinator. So some species of oak pollinate on the wind, or through the wind pollinates some species of oak. So how I can ask everybody now, what are some other pollinators? We know about bees. What are some others? Anybody? Anybody?
Birds.
Birds, yep. Bats, yep.
Moths.
Moths, lots and lots of moths. Moths are absolutely as important as butterflies. And?
Young kids.
Sure, two-footed, two-legged, absolutely. Maybe I'll keep going a little bit and then, okay. These are, well, okay, thank you, because that's going to come up in a little while. Yeah, the decrease in pollinators is caused by a multiplicity of human actions. Destruction of habitat across the planet, paving, more paving, because guess what buildings are typically?
Impermeable.
Impermeable. They count as pavement too, unless they're covered in plant material or partially, unless the square footage is made up for. And pesticide use, the G word, glyphosate, have people heard of that? Glyphosate? Glyphosate use has increased 15-fold in the past few decades. Not decreased, increased. And it's continuing to, because it goes in tandem with genetically engineered crops. So organics is absolutely critical for pollinators. And what I had not mentioned about, thank you, about every single spot where we can delete concrete helps with pollinator corridors. Have people heard about wildlife corridors? Yeah. So pollinators as part of wildlife are absolutely dependent on, especially in urban areas, as close in as possible so that they don't have to expend a lot of energy searching. So every little bit counts. And putting planters on concrete, if you can't delete it, that counts too. Every flower pot, every planter absolutely, definitely makes a positive difference. So I'm hesitating here a little bit, but because I'm going to say something possibly out of the ordinary. And I feel morally compelled to do this because I know the information. So are people aware of something called EMFs and RF, radio frequency radiation? Have people heard about that? Yes? Okay. So there is gathering volumes of research that shows the correlation between the rise in all of that with the decline of insect populations worldwide. And for those who would like to learn a little bit more about that, Sydney has 4 links that I've sent her that she can send you. The 4th link is actually an article in a Midwestern newspaper, which is quite informative, and it includes an interview with Joel Moskowitz, who is the director of the Center for Family and Community Health at the UC, at Cal, School of Public Health. So, thank you for letting me share that. So, the world is in environmental crisis because of our actions, and because we've really strayed from nature's ways, like someone was mentioning earlier before we started. But the good news is that nature is super resilient and has shown us that already. And so when we get back on the non-straight path, because nature moves in curves, not linearly, we really, as far as I am aware, it is definitely possible to turn things around. We just have to get on it. And so thank you, thank you, thank you for hearing this information. And it definitely, the climate crisis and the ramifications ecologically of that absolutely need us to follow nature, because renewable energy alone will not cut it. As necessary, of course, as it is to get off of fossil fuels. So, there's an indigenous axiom, which everyone is probably familiar with now. Water is life. Have people heard that expression? Absolutely baseline, factually, scientifically, and every other way, what is, including pollinators. And the good news recently, in terms of the rain that we've gotten, is that for the first time in many years, there's been mud enough for a butterfly called silver blue to appear, to reappear. They love playing in the mud. And so the action of deforestation, removal of trees by human beings, has also affected the natural hydraulic cycle, the natural water cycle across the planet. And the removal of trees through deforestation contributes significantly to drought. So it affects the moisture that pollinators need, and all plants need healthy soil. And for soil to be healthy, what does it need? Water. And as a baseline, it's the baseline of everything. Trees breathe out 250 to 400 gallons of water per day, depending on the species and the time of year. So the presence of trees, their pollinating action, of course, is critical, and their presence for the continuation of all life, including pollinators, is critical. 25 to 50% of trees, depending on the species, is made up of water. Each tree, 25 to 50% is water. People know about the Dust Bowl in the 30s. That was actually precipitated by deforestation in those areas. And it was turned around by President Roosevelt decreeing, and then the government hiring people to plant trees. It was literally turned around by planting trees. So, this is a compilation of, next slide, please. All pollinators need what we call these guys. What do we call them? Most people call them weeds. Pardon?
Ground cover?
Beautiful. That's exactly what they so the yellow one in there is this plant right here, which is ablaze all over the East Bay right now. It's a kind of oxalis, and people call it a weed, and it is vital for the first bees of the season. I would like to suggest that we delete the word weeds and substitute the word volunteers for weeds, because weeds have a panoply of quote-unquote ecological services. They come in first thing after fire and start populating to cover the soil. They provide nutrients for the soil. They provide moisture holding capacity for the soil. They feed pollinators, which these guys do. This is oxalis and clover. Clover is vital for a panoply also of moths and butterflies and other pollinators. And here on an ordinary old Berkeley sidewalk is a bunch of food for pollinators. In the corner, in the upper left-hand side, those are what? Leaves. Leaves left on concrete, not in the way, not for anybody to trip on, but those leaves are in the process of producing soil. And they're also homes for overwintering insects that become pollinators. So this, I want to pass this around for those in the room. This is a quote-unquote weed that's very common around here now called gallium, or for herbalists, it's called cleavers. And it's fantastic medicinal plant as well as a pollinator. This plant, has anybody ever seen this plant? Do you remember what it's called?
Or is it?
No, it's called, pardon? It's called pellitory. And it's a vital plant for red admiral butterflies to lay eggs on. I am not suggesting that anybody should keep every single volunteer that comes into their space, but as many as is feasible for the pollinator's sake. Could we go to the next slide, please? Photo, please. Everybody knows that plant, right? The yellow one. It's a phenomenally important pollinator plant. It's a phenomenally magnificent human medicinal plant, dandelion. And it's a soil healer. And it's a volunteer right there in the Berkeley cracked sidewalk. The other plant is also a pollinator plant. It's a volunteer too, but people plant it, but it spreads. Erigeron, that one's called. So that one's actually sold, although it moves around as a volunteer. So there's clover and oxalis and gallium right here. And then next slide, please. And next photograph. Okay, so there are a bunch of pollinator plants in this photograph. There's nasturtium over there. This is mallow. This is a wild, quote-unquote, weedy mallow on the right, with big leaves there, which is, again, a vital spring plant, and it's also medicinal for human beings. And in the middle is, anybody know?
Fennel.
Yeah, I'm gonna pass it around so people can mush it and smell it and enjoy it. Fennel is on, unless I'm out of date, I would love to be out of date on this, is on the California invasive plants list, which is maddening because fennel is such a gift to wild freeway areas. Where nothing else will grow. On the edges of freeway concrete, freeway on and off ramps, fennel is there robustly providing food and shelter for a myriad of beings. We shouldn't eat any of the fennel that's in those situations because it's polluted from our perspective. But for the pollinators who we have made desperate, it's a magnificent plant. And so what is the definition, really, of invasive? Could we change that like we can change the definition of a weed? Who decides what is really invading? Isn't it really two-leggeds that have invaded a lot on this planet? Nature moves. Nature doesn't know political boundaries. It doesn't know cultural boundaries. It doesn't even know continental boundaries. It's life, it's robust. And nature doesn't make mistakes. Whatever plant comes in to a space, there's a reason for, and like with the ones we've called weeds, if we look more closely and if we understand our environment, then we can gather the knowledge again, and that indigenous peoples still carry and are alert to, of why a plant has robustly taken over. What we call invasives robustly take over. But nature has a reason. There's either a nutritive lacking reason, or there's some other kind of imbalance to make a plant be quote unquote invasive and quote unquote take over. And fennel is a perfect example of something that, from an ecological and pollinator perspective, is quote unquote mislabeled, miscategorized. So let's see. Could we go to the next one, please? We can, yeah, thank you. We could move it up. So here's a pollinator. Absolutely, this is on a very, very busy street in Berkeley that is considered actually a highway, but it's residential and it's mostly concrete. And the garden that we made, including fennel, is vital for a continuation of pollinator corridor. So bees, we know, are the pollinators that are spoken about as the most endangered. Anybody remember at this point what some other pollinators might be? Because you named a lot of them, but not all. Ants, beetles, multiple kinds of wasps. And bees, there are some approximately 20,000 bees that are native to this continent, and approximately 1,500 of those are indigenous to the territory called California. You can go to the next one, please. So, about poppies. California poppies typically are orange, right? But there's one color in here that is hybridized by humans, and another color that is from nature directly. So California poppies come in a variety of colors. And guess what? They are not only for California. They are not only from California. They're Arizona poppies, they're Southern Oregon poppies. So the term native, along with invasive and along with weeds, is also a little bit tricky because, again, nature moves. And where nature puts plants, there must be a reason. And if we think about it, if we think about the political jurisdiction called California, there are so many microclimates and micro regions. There's the desert, there's Mount Shasta, there's the Channel Islands, there's the Central Valley, right? And they're all called California. But plants that are thriving and that people have culled and are now in, at nurseries for us to buy, from the Channel Islands are not necessarily appropriate for Walnut Creek, for example. So let's approach all plants, but particularly pollinator plants, as are they good and appropriate for the region that we're putting them in, for the ecological niche in which we want them to grow. And the other thing about poppies, California poppies, because there are of course lots of other kinds, the other thing about this kind of poppy that ranges from Southern Oregon through California and Arizona is that they are desperately needed by pollinators and magnificently medicinal for human beings. Native tribes use every single part, including the roots, medicinally and nutritionally. And the long seed pods, if you leave them there after the flowers have been spent, have been used to help babies be weaned, for babies to chew on. And has anybody ever heard of flower essences? That's a topic. You have poppy is a flower essence. It's a food. California poppy is a food and an herb, medicinal herb. So may I have the next photograph, please? And this is a scene, again, in a small urban garden, which is chock full with small plants and large plants. So particularly in an urban space, we want to have things be as chock full as possible with diversity of size and shape and color, etc. So next photograph, please. Can everybody see that okay? It's a little dark, but this is a hillside, and it's a mixture of what we call California natives and what we call, quote unquote, exotics. So there is the preeminent California native bee researcher named Dr. Gordon Franke, who happens to be at Cal. And his experiments, his research along with his students, has found that what are classified as the 1,500 approximately California native bees thrive most robustly when they're in an environment of mixed plants, mixed quote-unquote CA natives and others. So that's what this scene is. And the plant that's lavender, that's across here, that's called scabiosa. And aphids love to gather on the stems of scabiosa. And that brings in ladybugs, because ladybugs are pollinators too. So the ladybugs come and eat the aphids, and then the aphids don't have a chance to hurt the things that are not strong enough to withstand them. But also, just to insert here, never really worry about aphids. Do people know what aphids are? Okay. Because they can be hosed off or squished, and they have 2 life cycles per calendar year, per 4 seasons. They don't hang around all the time. And if there's a plant, a pollinator plant or otherwise, that is very adversely impacted by them, that is showing that that plant is not in its appropriate place or its appropriate soil, or there's something to address about that plant. Otherwise, the aphids wouldn't be damaging it, or wouldn't be harming it. Because damage and harm are different for pollinator plants. This, if people can see it, is a borage leaf. And the hole in it is a tremendous, I'll say something else why I want to pass it around. If you find holes in your plants, rejoice, because that means that most likely it's a caterpillar that is absolutely vital, that is eating that plant, a moth caterpillar, a butterfly caterpillar. And this leaf, borage, phenomenal pollinator plant, the flowers. The flowers are edible, and so is this leaf for human beings also. People, bakers candy the beautiful blue borage flowers, and pollinators of all varieties love them also. So let's see. Okay, so the concept, along with natives, of local, it's very, very important to be 100%, 2,000% chemical free, rather than focusing on local. I just want to say something about that, because, as we said, nature moves. So a plant is local to the planet. May I have the next one, please? So this is a melange of delicious pollinator plants. Nasturtium, I blank out on the name of that middle one, so forgive me. And the one that's white with a burgundy center is a kind of native to this territory, to this area, linen or flax. Linen is made from a plant called flax, and fantastic pollinator plant. So next one, please. These are all pollinator plants. So the grasses are spaces for various pollinators at various stages of life to hide or to make habitat, even though they do not flower, or they're not flowering now. But also the flowers of grasses, of perennial grasses, are very important across the board for across-the-board pollinators. And this particular space, like the first photograph, is out in the open to deer. So these are plants that deer don't touch. So for our area, that's kind of important. May I have the next one, please? This is just a small photograph again of a small space packed with plants, and the red one is called a butylon, and that's a pollinator plant. The other one is for design. And the next one, please. So, as I said, everything needs water, including pollinators, which include birds. So any kind of water feature that you can include is good. And for butterflies, little bitty saucers are great. You can put some gravel in them or a little bit of soil, which becomes mud in the saucer, and they love that. And butterflies actually, some butterflies, not all, love rotten fruit. So this is, again, a small urban space by a sidewalk in Oakland. And let's see, okay. So, may I have the next one, please? That is a quote-unquote California native, which is right here. I wanted to show you what it looks like. Again, another spot that's very, very urban. And the plant at the bottom is a volunteer in many sites across the East Bay, including, if anybody has ever noticed the plants in the median strip on across the street from the North Berkeley Bar. Is that Sacramento?
Yeah.
Yeah. So this plant is called Centranthus rubus, but there's also a white one. The wind or bird droppings or who knows what has decided to beautify the gravel space in the median strip, which has bark underneath it. Fantastic pollinator plant, a lot of pollinators. So enjoy the volunteers. Again, I'm not suggesting you have to let them take over or that they shouldn't be culled in any way. Just know how incredibly valuable they are. Next one, please. Oh, I didn't tell you the name of this, called Cecilia viscata, Viscada. And it's a spring annual. So, another, as I said, just an example of what the variety of style and plant choices we can have in urban spaces for pollinators and for people. Next, please. And this is a bunch of actually natives, quite a few in here. There's ceanothus in the background. It is not in flower in this picture, but it's actually this plant right here. It's called Dark Dancer. I think that there are so many magnificent cultivars of ceanothus. Yeah, Dark Star is what this one is called. And don't believe labels, because this label, for example, says 5 by 8, and it's really 8 by 12, or it can get to 8 by 12, 8 by 10 to 12, but you don't have to let it get that. And for the people in here, you might want to come and smell it later. We won't pass it around. So let's see. And then there's a different kind of Cecilia, as in the blue, which I don't remember the specific name of. Then there's Mimulus, or some people call it monkey flower, in the red there. and some poppy in the background. Oh, and this is called California fuchsia. It is about, you can see a teeny, teeny bit of orange there. This is a garden, it needs no water of any kind, gray or otherwise. So this is a vignette of plants that need basically no water if we've had rain. No supplemental water if we've had rain. And since that can be iffy, a little bit once a month maybe will extend their flowering period. Now the next one, please. So, people know what this plant is? Yeah, zinnia.
Zinnia.
You can buy them in any, any nursery. I won't say the big box store, name it. They're magnificent pollinator plants. They're annuals. They need a tad of water. They need to have good soil. And good soil is soil that has been addressed in a way that it can hold moisture to a degree. But they provide nectar and pollen, and they're very easy for many kinds of insects to access. So that's very important. And they come in all sorts of colors. So let's see, next one, please. Do people know that roses are edible? So this is an example of that. So there, I want to back up a little bit and reiterate some pollinator principle basics. Does anybody remember what the first thing I said? Zero, absolutely none, no pesticides. Zero pesticides. Anything that has side, C-I-D-E-S, at the end of it, it's a killer. It destroys. So you do not want to use that. And what I mentioned a moment or two ago about soil and zinnias, the next thing after water that all plants need, and thus all pollinator plants, is healthy soil. So how do we make healthy soil? On concrete or otherwise? Leaving the leaves on the soil. Leaves become the soil, and leaves are actually homes for various overwintering stages of pollinators' lives. They're definitely pollinator habitat, leaves are. And soil that has been nurtured ecologically is a carbon sink. It sequesters the most carbon. And of course, what I had forgotten to mention was that the vitality of trees vis-a-vis their carbon sequestration, but also all plants, to one degree or another, sequester carbon. So the more plants in an urban environment, the better. And also for heat island effect, to mitigate heat island effect. So it's all, everything's connected, deleting concrete, water, healthy soil. And this is not for urban environments, but I like to share the information with people that cotton, unless it's organically grown, is genetically engineered. So what does that mean? Massive amounts of glyphosate are used. And that's total destruction in those areas of all pollinators. Cotton fields that are organically grown filled with pollinator plants. So it's very important to know that organics across the board, whether it's in cities for people's food or otherwise, it's all connected. And in terms of the sidewalk photograph with the leaves pushed off to the side, that's perfect for a sidewalk area and an edge. In our gardens, in our urban gardens or anywhere else, messy is actually marvelous. Think of a forest or the woods. It's a melange, it's rambunctious, it's not segmented. And that's what we actually need to emulate. So when you clip plants for whatever reason, check to see if the stems are hollow and leave them right where they are. Or once you've discovered that a particular plant has hollow leaves, don't cut them for a while because they're pollinator homes. And making little twig piles, not big things that could catch on fire, not referring to that at all, but leaving small piles of leaves around your garden space, of twigs, that's really critical for pollinator habitat also. Making small rock piles anywhere is very important. And also leaving, because in the rock piles, they have crevices, and they also gather soil by wind blowing there, and those are spaces of pollinator habitat. There are some bees which actually make their homes in bare soil. So we really do want to leave in some space, whatever place we're gardening or planting, we really want some bit of uncovered bare soil, whereas most places we don't want to leave the soil bare. We want to leave the leaves on the soil or other kinds of mulch. Some places leave for the ground-dwelling bees. And I don't know where that leaf went, but here's a nasturtium leaf that the plants, as I showed you with the borage and with this, totally healthy plants. The caterpillars are not hurting the functioning of the plant. This one appears has been eaten on the sides too. If you find a rose leaf particularly, or other kinds of plants also, that has a crescent cut out of the side of the leaf, like from the olden days, a hole punch, like half of a hole punch, that's probably made, well, basically, virtually definitely made by what's called a cutter bee. So no worries about holes in plants if the plant is basically healthy. Rejoice that you've got pollinators in one stage of life or another, because we want to feed caterpillars as well as the winged ones and the crawling ones. And in terms of the soil, the living beings in the soil, the microorganisms in the soil, are also the carbon sequesters that are critical. So for the pollinators' sake, let's see, could we go to the next photograph?
I did also want to give you a time check, just because I want to make sure that Massey has enough time to present as well. It is 12:54.
Okay, I will talk fast.
I can go through mine pretty quick too, so.
Okay, that's the centranthus, this is the Phacelia, and up here is snapdragon. Snapdragon, if it's organically grown, is a humanly edible plant. And what I was going to say is, I think I just did say, maybe I didn't. Pollinating beings need both sun and shade. And in terms of the soil and mulch, please, no plastic. And please, no what's euphemistically called landscaping cloth, because that's plastic too. And both of those, in addition to the fact that they're plastic, they prevent soil health. They prevent the life of the microorganisms under that area. And you also want to avoid chunks of bark. So let's go to the next photograph, because I think I have some. Okay, so this is, I'll skip this. That's a native, that's not. This is Ceanothus, and at the bottom, that's this plant here, which is Alisa. Magnificent, incredible pollinator plant, multiplicity of beings, and if it's organically grown, it's also edible. And that's a salvia and a rose, so this is, again, a different urban sidewalk squished in there, and the one sort of the green one at the top on the left, that will be flowering. That's a passion flower vine. All of these very needed plants, and easy, almost zero water in a very urban space. Well, go ahead. So this is another showing of what I just said. Go ahead. And this also, teeny weeny space around a stick of a tree in between the sidewalk and the street in Berkeley. And just, alyssum, et cetera, for pollinators that we packed in there. We were allowed to remove a tiny bit of the concrete, and we used every inch of it. Keep going, please. This is just showing a variety of styles that can fit into tiny urban spaces. Go ahead. So this is actually a relatively important photograph because it shows not only a variety of quote-unquote California natives and others, and bright colors. I had forgotten to say that. Bright colors are critical for pollinators to have somewhere in the scene. It doesn't have to be 100%, but as many as possible. They love it. The dry stacked walls, dry stacked rocks are very important because in those dark spaces there, which are soil, that makes habitat for a multiplicity of pollinators also. And the tiering of the space helps with water retention. So go ahead. So I had mentioned, nature moves in curves. Very important for water capture, for holding water on the site, and for flow. Camellias are also edible in certain, these are camellia flowers in certain instances. Go ahead. So this is just another example of a curved pathway, and with leaves left on the side. Oak leaves are very, very important. I may have said this, forgive me if I did. Very important, leaving on the ground for pollinator habitat. This is a mixture, again, of these plants. The curve is important in the pathway, and the material, the surfacing is permeable. And when a stray volunteer that you don't want in the middle of the pathway, I'm not suggesting having volunteers crowding out where people need to walk, because it's a permeable surface, they're very easy to pluck them. And that just happens to be recycled redwood treads there. Next one, please.
Don't worry, it's all good.
Okay, this is an example of if you have a straight concrete space, you can make a curve. Keep going. And this one is simply, even a formal quote-unquote setting can have pollinator plants infiltrated everywhere possible. So you can see at the base of everything are pollinator plants. Go ahead. And this is an example of another permeable surface. And again, when volunteers come, easily plucked. Go ahead. Hummingbirds are pollinators, and they need shade as well as bright colored flowers in the sun. Go ahead. This, although it's dark here, is a monarch. Monarchs also need shade and sun. Keep your head. And that's the Centranthus in white. Go ahead. Oh, you know what? These, what are these? Anybody know? Monarch caterpillars. It's really hard to see it in this photograph. I mean, it's dark. On my screen, when I look at this photograph, it's brighter. But there are a whole bunch of them. The next photograph, please. And that's the same plant after they've eaten, but they're still eating. So you really do want to let them eat. And eucalyptus are vital plants for monarchs. I'll leave it at that. If anybody wants to ask me more about it, please contact me. There's lots of research on it and people's quote-unquote on-the-ground experience. Eucalyptus are vital for monarchs. They have, to use one of the words we were talking about before, they have adapted, but they are naturalized. They were brought here in 1850, and now they have naturalized. And in fact, I have to say one more little thing. It's a myth that nothing grows under eucalyptus. Many pollinators hibernate, et cetera, under eucalyptus. And they're very necessary for other microorganisms. Okay, next one, please. Okay. So, again, this is an example of a melange. Edible, native, go ahead. Oh, well, there's a bee. And next one, please. So, lavender is also edible, and I will stop, but, if I can,
Please.
this flower is called a bachelor button, and if it's organically grown, it's edible. And so afterwards, anybody can ask me about these plants. Thank you.
I was more interested in what you were saying. I know what I'm saying.
And I actually, one more thing, parsley, herb, thank you, Massey, herb flowers, vital for pollinators. This is parsley, super good if you want to come and take a bite of it. Human bite of it. That is organically grown. Thank you, Massey.
Of course. Thank you for having me. I had two motivations for coming. One was just to come hang out with Alisa, who I haven't really spent time with in a while, but it's great to hear about your work. Yeah.
If you move the blue plant, it's blocking
Oh,
the
yeah,
camera from you.
Totally. Talking to Ceanothus. And two, because I haven't been that connected with the AIA, and but I've been involved with natural materials for a long time, 20 years. And I now direct a nonprofit, and so I just kind of wanted to say hi and get on your radar. And you know, there's some interesting resources in the East Bay that you might want to be aware of. That this is an interesting area to you. And so this is just a really quick overview of my work and how I think about it. That's my house, by the way, behind. behind the letters there, it's a clay straw remodel of an existing funky old stick frame up in Elsa Fronte. But the surface you're looking at is a clay plaster made from literally the clay from that quarter-acre site in Elsa Fronte. So jumping ahead a bit, but one thing I've been exploring is the urban applications of natural materials. Next slide. You just scroll down. Yeah. So who am I? There you go. I spent a long time with mud. My current, I have spent 20 years in what's called the natural building movement, which has different faces here and in Europe and in other parts of the world. But it's basically a collective relearning and sometimes reinventing of traditional vernacular building that can look a whole lot of different ways because it's vernacular building in different parts of the world grows from what is there, and what your climate is and what your local materials are, and so there's this incredible richness of traditional practice that a lot of which has been basically forgotten and people are relearning, and so this is a wormhole I won't really get into, but that's kind of the basis of my work, and it was a DIY movement here and it still is to some degree a DIY movement until pretty recently, and I've become one of the people helping to grow it into just other arenas. So I was a hands-on practitioner for a long time, and I still do some of that. But I'm currently the director of the California Straw Building Association. I'll probably spend most of my time talking about that just because it's this incredible little node of really smart. Like we have one of the best nodes of technical people around natural materials in the East Bay in the country. And so again, just something to have on your radar. I work as a natural materials specialist for Verdant Structural Engineers. I'll talk a little bit about this later, but they got an EPA grant to develop a panelized straw-based wall. And so I'm working on that with them. And then I do some independent consulting of various types. Next slide. So what is natural building? I spoke about that a little bit just now, but it's taking local materials. I mean, also the movement itself has been talking for years about what can we call ourselves something else? This is very vague, but nobody's ever really been able to come up with a better name. It overlaps a lot with bio-based building, generative building, so there are all these there's like a Venn diagram of things that all sort of focus on these principles. But what it looks like in practice is taking these ingredients, the most common sort of native ingredients, and making a whole bunch of different wall systems, finishes, and floors out of them. In modern practice, typically you're working with wall infill, sometimes structural walls, wall finishes, and flooring types. That's sort of the purview of natural building. Next slide. Origins to the right, a couple of two very different vernacular traditions. The upper picture is an earthen village that's still inhabited in Burkina Faso, one of the most spectacular earthen plastering traditions in Africa. And then the lower building, I think in the UK, it's a timber frame straw clay infill barn, and it looks like it's brick too. The 14th century or something in the UK. And then modern equivalents. So on the right the upper picture is a cob landscape wall that I actually built on the campus of Swarthmore College as an art install a while back. That was interesting. Cob is very similar to adobe in that it's a clay straw mix that you shape in place. And I totally forgot to bring it, but we did just write the updated book on cob construction. So there's sort of this ongoing building of the library of modern building science and things like that for these techniques. And the lower right is, if you've heard of natural building, you've probably heard of straw bale because it's been the most kind of prominent. That's a straw bale house in Sonoma. Right, next slide. So two very common types of natural wall systems. And I am doing like a pretty quick overview here, but I'm happy so I'm not really doing a deep dive into like all the types of natural building, but again, just, happy to be on your radar, happy to be a resource if you want to know about it. But two very common types, again, that's a straw wall going in on the right, on the left, sorry. Non-load bearing insulating frame, that one is my friends at Crafted Earth, that's being built in Santa Rosa, they're plastering now, so I'm consulting on the finishes for that one. That was like the fussiest fail install ever. Side note, but they had to modify like every single layout, which you don't want to do if you're designing for straw bale. And on the right, this is a cob, a small load-bearing cob structure in North Berkeley, actually. This was built by actually an old apprentice of mine when I was doing more hands-on work, but she had a design degree and wanted to build a project that expressed her values as a designer. We decided, well, let's get a permit for, this was before, to back up a moment, a lot of what the community has been doing has been writing code. And so straw building has had code written for it for several years, but the cob code is just now being implemented. It was written by colleagues of mine here, actually, and I was somewhat involved in the code writing process for cob.
Can I take a question there? So the one on the right, you have a way to demonstrate that it kind of meets the building code.
Well, we wrote the code for it. That kind of evolved from this.
So it is in the code now?
It is in the code, and there are restrictions for seismic zones. This was built, we built this as a way to demonstrate we went through the alternative means and methods as a way to demonstrate the compliance with the information that we had at that time. So we had done some seismic testing with UC Santa Clara and some other people, some compression testing, and we still need to do more of that. But this building, my joke about it is that it has the most, it holds the Guinness Book of World Records for the most intellectual capital invested per square foot. It took us 3 years to get the permit with the Berkeley Building Department who wanted us to get it, but they had to kind of work out like what are we even making equivalency for? Because if you don't have a cob code, then you have to prove equivalency. And they were like, is it masonry? Is it like what are we doing here? But we did get it through, and now there is. That building actually helped my colleague Anthony with Burden Structural, who was a lead writer on the cob code, come to understand how to formulate the questions we needed to ask to be able to create that code. So, very cute little building with an outside impact, hopefully. Next slide. Yeah, just some fun pictures of what natural plasters and finishes look like. The upper right is an earthen floor. The lower right is actually clay. So if you've torn apart houses around here, you know that plaster and lath is common. That's lime plaster. So you could do an earth plaster version of that. So that's a new, on the right, bottom right, clay earth plaster.
That's like from American clay?
No, that's my specialty is the thing I still do most is mixed design from site soils. And so that one that's in Petaluma. And the surface finish is a bagged clay custom mix, but the mix that is on the lath is the site clay that's very hard.
Because in my experience with the applied clay, like American clay,
Yeah.
it looks nice, beautiful, it's easy to put on, anybody can do it,
Yeah.
but it's not really strong with scratches and stuff like that.
Yeah, clay is soft. There are some coatings you can put on it that make it more wipeable and harder. I don't actually work with American clay that much because I mostly have worked with site materials. And also, if you're going on the straw, American clay is formulated for sheetrock. Yeah. And so I'm typically working on another wall system, and so you wouldn't really work typically. People, and some practitioners do. I typically haven't used American clay on top of, this type wall. And then on the left is actually my bathtub, but I put it in there because there's Tadillac is this incredible lime plaster that's become kind of vogue in the natural building world, but it originated from Moroccan water cisterns, and so it's a lime plaster which sets. Lime is kind of a concrete relative, but somewhat lower in fact. But they burnish it with olive oil soap, and it makes this incredible surface that I don't do a whole lot of Tadillac for other people just because it's pretty specialized, but I wanted to see if you could actually make a cut out of it, and you can. So, next slide. Another example of a more typical earthen floor on the right, but that's poured on top of a wood substrate. So you can do earthen floors as remodel, and then just another sort of more typical earthen plaster on the left. Okay, next slide. I thought you might enjoy this. This is an earthen floor going in on an earthen base floor. So this is a fire rebuild, and the walls actually are straw bale. This is I don't know if you know where Pie Ranch is, it's down by Santa Cruz. Really cool educational farm.
Or do
organic, working on soil carbon in some very cool ways. They actually grew the straw that's in the walls of this building, and they lost their old common space. The whole farm didn't burn, but they did lose their common space in the 2021 fires, I guess. The CC, whichever year that was, the CC fire, I forget. But so we're just now finishing up the rebuild, and the base earthen core is their site clay, as with the base plasters, and then this is what our finished floor looks like going in. It's that one's about an inch thick. You can go down to 3/4. Next slide. Oiling it. So earthen floors work because you pour them. It's actually a lot of sand and a little bit less clay, and then you just saturate them with linseed oil, and the linseed oil hardens. And so the curing process is rather slow, but they're wonderful, soft, like, I don't like to call them alternative to concrete, but they're like having a concrete floor, except softer, easier on your body, easier to repair. You can wax them, you can rethin. So, next slide. Okay, so to talk a little bit about California Straw Building Association, which I think might be of most use to this group. It's been around for 25 years, and I co-directed with the previous director, who you probably know, Arkansas Architects. I've worked a lot with them. Known David and Manny since I started building, really. I co-directed the Caswell with David for about 4 years, and then took over directing last year. And we also, it's the Straw Building Association, but it's really an umbrella of just like natural materials enthusiasts, and a lot of the really technical people are part of our community. I'll talk a little, I'm going to get into talking about carbon, mostly because it's just like leveled the playing field for natural materials in a really interesting way. And so we're watching our world change kind of rapidly, but scaling up our technical expertise is something that's being asked of us. And so we basically, our mission is to further the practice of straw building. In practice, we support code writing of various types. We support technical research of various types. We do hands-on training. We're starting to do EPD LCA research, which is my project. And we serve pretty much anybody who's interested in helping scale bio-based natural materials, but design community, hands-on, DIY builders, other nonprofits. One kind of interesting thing about natural building is that until very recently, it's not product-based, it's all process-based using what I call open source building, just available materials. You don't have all the mechanisms that tend to drive financing of testing. Like there's not somebody making money off a product and then will like do the whatever technical testing you need. And so this family of nonprofits has grown up in place of that, that does that work, but it means that you have this, it's kind of hard to communicate, but it's this completely different experience of what built environment is, because it's open source, it's shared information, nonprofits doing technical research. Where our conference is coming up at the end of the month. And it's really fun to try to describe to people who are joining the community, like what it's like. Like it's just not like, normal conferences. It's sort of this cross between pretty technical conference and like this enormous community retreat, where people are just like, let me know about the conference. It's very fun. It'll be near Assembly Obispo this year. We kind of hop around the state. But we have people who come, actually now we have Europeans who come, we have people up and down the West Coast who are part of the team. Cool, next slide. This is actually our 2022 slide, but it's all the stuff we're still working on. LCA work, workforce development, kind of off and on. Regenerative supply chains, or just really just supply chains, and thinking about bioregional supply chains, which we'll talk about a little more. All sorts of ongoing code and testing work. We need to do acoustic testing for straw bale party walls, or just straw insulated party walls, different types of straw insulation, various types of training resources, and then some insurance work, just helping to create more. So it's like kind of a snapshot of stuff we work on. Next slide. So I'll do a little more of a deep dive into straw as a kind of an example of natural materials. Partly what I'm thinking about a lot right now, but it's, a lot of the patterns are similar for hemp or for bamboo or for working with clay, similar implications. And the cool thing is that straw is a carbon storing building material. Next slide. How can that be? As Alisa said, the job of plants is to take atmospheric carbon and turn it into biomass. That's what photosynthesis is, basically. Straw mostly comes from, straw is grass. Straw and hay are different because hay is grown for feed, so it's cut green and it's got nutrients in it, which means that it composts easily, so you don't want to build with hay. Straw is usually what's left over after you've grown an annual grain crop. These are the most common: wheat, rice, oats, barley, rye. And you've harvested the grain off the top, and all the nutrients were in that. And so straw is mostly carbon and silica. There's not much else in it, so it doesn't really like to compost unless it's quite wet. It needs to get pretty saturated to really break down. And the carbon in the stalk was atmospheric carbon. And so typically in sort of the normal life cycle of straw, it's, you want it to break down and go back to the soil. But once that straw breaks down, the leftover, the stored carbon goes back into the atmosphere.
Is the carbon that it gets from the atmosphere nutrient?
I guess it depends what you mean by a nutrient. It's the building block of the plant itself. So photosynthesis is basically absorbs carbon dioxide and produces sugars, some of which are given to the soil, but a lot of which make the plant itself. So I guess you could say it's a nutrient. But if you take that straw, that building material, and you prevent it from breaking back down, which is what you do when you put it in straw wall, you effectively store that carbon for the lifespan of the building. And so, measurably, the numbers are actually pretty easy to run. And there's just not really any other building materials that do that. Next slide. Oh yeah, a little bit about, I've referenced straw bale building a lot because it's kind of the flag, what people tend to know about straw building, but there's a bunch of other ways to do it. There's a formed system called light straw clay that originated in Germany, actually, like 7 centuries ago, that you can make varying wall thicknesses with. You form it up. There's increasingly a lot of prefab straw panels. I mentioned that I'm working on one. There's others. Some straw block products that have been in development. People are playing around with straw MDF, though I think, I'm not sure what happened with that project. Cool, next slide. And then just a quick note on scaling up. Straw building has mostly been residential. It went from DIY residential to kind of high-end residential, and now there's multiple people looking at this is a straw insulated multi-use 3-story project that Arkansas designed in Mahonia, Oregon. And so the exterior is just conventional siding, and the interior is straw insulation. Next slide. So just a note that yes, we are thinking about scaling. This is the panel I'm working on. And then this is just a slide from one of our pitch decks. If anybody feels like investing in the panel, we are in seed round investment raise right now. We've got a couple of investors on board. We finished the EPA grant and then switched.
Is it thermally resistive to keep the building warm or cold?
Say that again.
Is the straw thermally resistive to keep the building warm?
Yeah. The one reason we're working on the panels is because you get about R2 per inch with bales.
How many per inch?
R2 per inch, and so you have thicker walls. But if you modify the straw matrix a bit, you can increase that. And so our goal with the panelized system is, one, to just have the advantage of prefab, but 2, to get the walls better. So you can, some people, most people who build with bales or straw want the thicker walls, but it's not always practical. And so our goal is we're halfway there, is to increase our value per inch so that you can do a 2x6 wall and have a high performance building. Anyway, so that's something, happy to tell you more about it if you want to hear about it, later. Next slide. Yeah, so this is what's really great is that some very mainstream entities are now understanding about bio-based materials and straw in particular, and its carbon superpower. I'm sure you know about the high carbon footprint of especially the rigid foams, or just insanely carbon intensive. Yeah, concrete. This is insulation materials, which is why concrete's not on there, but yeah, concrete is a huge carbon footprint. But a lot of what has been marketed as high performance, building materials from an envelope perspective are incredibly carbon intensive. And this is, I'll probably cover some territory here that you know already, but there's 2 components to climate impact of a building. One is operational carbon, which is what energy required to run the building after you make it. And the second is embodied carbon, which is all the emissions associated with making the building to begin with, so mostly the building materials. And what's interesting, for years and years, again, I'm sure you knew this, like the dialogue was just run by operational carbon, because the theory was that, 25% of a building's impact is materials and 75% is operation. There's a bunch of problems with that assumption, but what's really interesting is that that's true, but all of the embodied emissions are upstream, they happen now. And there's like a 15, I didn't put this graphic up there, but there's like a 15-year window that takes operational carbon emissions to catch up with and then surpass all of the emissions that got put into the atmosphere just through material choices before you even start operating the building. And so once people realize that, they're like, oh, it's really high leverage to think about materials now, because we have this window of trying to stave off the worst climate change. And then that just, it's provable that bio-based materials are like actively reverse that process, and so it just changed everything. So there's like massive government money coming out and going into, trying to scale up, dropping embodied carbon, supporting bio-based materials. And so, next slide. I love this is basically the same graph as the other in a different form, but I love that this comes from the Department of Energy. Like somebody in there got hold of this information and made this graph, and straw is like all the way over to the right. There's pretty interesting debates. I'm not going to go there. It's not even really my specialty, but like there's I don't know if you follow wood debates around carbon storage, but it's pretty complicated. And I have colleagues who are like, I do not credit wood with carbon storage because it's going to store more in a forest than in a building, which is not so true of an annually renewable plant like straw, even though that can be complex depending on agricultural practice. But just a note on that here they do put it over in the carbon storing ends. There is debate on that. Next slide. This is really fun, just to give you a sense of like how much that means in a building. Two of my favorite colleagues who are now on the CASBA board have done a whole bunch of carbon modeling on residential structures. And I didn't put the whole reference in here, but they basically took and they're East Coasters. So they took like a normal, I think what is it, 1,200 square foot house, and ran it through 4 scenarios. So one is just like normal business as usual, not particularly, high efficiency materials. What's that carbon impact? Like high efficiency materials or high, high performance materials, but conventional, so like foams, what's that impact? And then using normal bio-based materials like cellulose, and then using, as many bio-based materials as you can. Like, what are those carbon scenarios? And so this gives you a good, I believe the top one is not even the highest emitter. That's just like typical construction. But if you do an energy efficient building built with natural materials, you can sequester like 9 to 10 tons of carbon in like not a very big building. So that gives you, and versus emitting, up near 100 tons of CO2, combining operational and embodied carbon over the lifespan of the building.
We are getting close to the nominal end of the meeting at 1:30, just to let you know.
Yeah, I'm almost done, I think. Next slide. So what's fun about this, and this is the connection to what Alisa talked a lot about, is that because straw is a plant, it connects you to the ecosystem. And in that case, in our case, it's agricultural ecosystems, but you can make choices around what kind of agricultural ecosystem you're sourcing your straw from, to some degree, because also that's scaling up. Conventional grain growing is usually a monoculture. There is such a thing as regeneratively grown straw, which means growing several plants together that benefits the soil microbiome, which means you store carbon in the soil as well as in the building. Next slide. This is from a regenerative agriculture practitioner. And so a lot of ideas around regenerative building come from regenerative agriculture. And these are people who are like, how do you rebuild ecosystems by farming differently? This guy is wonderful and very famous. He's been at it for 20 or 30 years in North Dakota, a very dry climate. And I won't spend a lot of time on this, but he began to map his soil carbon, adding techniques of crop diversity, more cover cropping, more species, and then integrating livestock. And this is a whole wormhole I won't get into, but at the end, he has a very diverse agricultural ecosystem, and his soil carbon is just going through the roof, measurably. Next slide. So this, for me, regeneration is really, like carbon drawdown is a wonderful, I call it a gateway drug into ecosystem thinking. And so it's like, we do need to rebalance the global carbon cycle. Carbon's not bad, it's just all in the wrong spot. You know, we just need less of it in the atmosphere, and we need it in the soil. And so, when you support, and in the tree leaves. And so if you're supporting good soil management, you're supporting microbiome diversity. Not only are you reducing atmospheric carbon, but you're also building resilience, to be able to resist the effects of some climate change in the agricultural ecosystem and natural ecosystems. Next slide. I won't spend a lot of time on this, but I started to map out. I'm pretty interested in ripple effects, and so by designing with, this is an example of how you can design with straw and support both the sort of human ecosystem and also natural ecosystems. I think I'm asking more about this if you want to hear about it. I forget what my last slide is. Last two slides. Right, so really the point, in my mind, I like to call natural building habitat restoration for humans. And it's really a question of going from this is how our built environment currently works. Requires a lot of materials. The built environment and biosphere are separate. The built environment doesn't give back, and it emits a lot of problematic things. You sink a bunch of money into it, you sink a bunch of materials into it, it gives you back waste carbon dioxide and toxins. So we're going from that to, next slide, reintegrating the built environment with the biosphere, where it's a carbon sink. I mean, you know this, but basically the circular economy of the built environment, but also giving, employing how we build to actually give back to natural systems. There we go. I think I made it by 1:30.